Across the modern corporate landscape today, organizations are piping their most valuable asset into massive, centralized cloud environments. These foundation models are generalists. They know the entire internet, but they are ignorant of the internal logic that drives your business. This setup creates a high financial tax. Your enterprise is paying massive token fees and suffering latency delays just to process information you already own. Routing proprietary workflows through these public pipes also compromises your data sovereignty, exposing sensitive operational trails to external infrastructure. Public models cannot grasp your specific risk tolerances or your institutional memory because they were never trained on your history. Renting generic intelligence creates a recurring cost without providing a unique competitive advantage. The response is a shift toward a native AI operating system. This is the architecture of BYOAI, Bring Your Own AI. It is an inside-out strategy, moving beyond basic wrapper apps to build an intelligence layer integrated with proprietary systems. The primary objective is to decouple the enterprise from centralized cloud providers and establish a captive intelligence layer. Building this system requires a layered approach, starting with your data foundation and pushing execution out to the network edge. Architecting this native operating system has become a baseline requirement for modern corporate survival. The architecture begins with the bedrock of any enterprise, its unstructured historical data. In this environment, the model itself is a commodity. The true defensible moat is the governed proprietary data it processes. General text summarization offers little value compared to making your legacy case histories and internal workflows machine legible. Construction begins by ingesting disparate legacy databases, contracts, and compliance structures into a secure, unified pipeline. Isolated silos are systematically converted into a structured, permissioned, and searchable knowledge base. With this context mapped, the system stops predicting generic words and begins computing the precise strategic actions required by your business. Operationalizing your history converts AI from a public utility into a private capability. Effective enterprise intelligence does not require a system with a trillion parameters. Instead, it relies on a specialized engine, the local reasoning model. It acts like a master architect working exclusively inside your organization. Trained on the captive data layer below, its reasoning path is structurally unique to your enterprise. It ignores broad internet trivia to focus on unspoken institutional memory and your specific operational boundaries. Competitors cannot buy access to your history, making the LRM a permanent and uncopyable intellectual moat. To drive actual workflows, this static brain must be translated into an active execution layer. This is where we deploy headless agentic thinkbots. These systems bypass chat windows and do not wait for human prompts. They live within the infrastructure, solving problems autonomously at the speed of your data. These thinkbots rely on a dual-engine framework that provides both fixed memory and dynamic reach. The first connection uses RAG to pull in historical policies and fixed internal guardrails. The second connection uses the Model Context Protocol to reach outward, ingesting live telemetry and fluctuating market feeds. At runtime, the agent synthesizes those static RAG rules with live MCP telemetry to adjust its logic path on the fly. Standardizing this framework transforms AI from a simple text generator into a trusted operational actor. This brings us back to the recurring costs of centralized inference and the energy waste of constant cloud communication. A native OS addresses this by compiling the LRM stack directly onto on-premise servers and field-deployed edge devices. Running workflows locally eliminates the cost of millions of recurring API tokens. Energy footprints decrease as compute happens on optimized chip architectures at the point of need. Local execution also provides near-zero latency, making decisions immune to cloud downtime or network congestion. Executing sensitive workflows locally also ensures that your internal data is never broadcast back to a global server. Edge inference shifts the financial model of AI, delivering local value while removing the dependency on centralized hardware providers. This architecture is particularly effective when scaling intelligence across varied global markets. Western-trained public models struggle with localized languages and regional regulatory nuances. As the unified global network shatters into distinct regions governed by rigid data boundaries, this localized information must adapt instantly. By nesting governance into edge nodes, the native AI OS forces the model to comply with regional data residency mandates automatically. Cross-cultural logic and legal compliance are core architectural features of this system, rather than post-deployment fixes. We see this most clearly in the challenge of digital financial inclusion in frontier economies. Traditional banking grids often fail these markets due to inconsistent bandwidth and unreliable infrastructure. A localized edge AI bypasses this grid. It can underwrite microloans and verify identity patterns directly on a mobile device. Internal logic gates block fraud instantly without transmitting sensitive user data to an external cloud. Organizations must view intelligence as a sovereign asset that must be generated and controlled internally. A captive, edge-deployed cognitive infrastructure is the definitive baseline for enterprise survival in this new environment.